Hey guys, Mrs. Lyons here. I did want to take a quick couple of minutes and make a quick video of how we are drawing Lewis structures for covalent compounds, and then how, based on those structures, we are determining the shape of the compound. I had a couple of people ask if I had a video, and I thought, what a better thing to do on a snow day than make a video of drawing covalent compounds. So the first compound I have here is CH4. Okay, as we've said, typically the atom that is in the middle of the compound is listed first in the formula. However, the better way to double check is the atom that's in the middle is going to be the atom that can make the most bonds. Okay, so let's just kind of look at carbon and fluorine and figure out which one of those can make how many bonds. Okay, so if we look at carbon, if you look at carbon on the periodic table, it's in group 14. This tells us it has 4 valence electrons. So I'm going to draw my valence electrons, one on each side of the atom. Okay, so that's the Lewis structure for carbon. If I look up fluorine on my periodic table, it's in group 17, which tells us it has 7 valence electrons. So the Lewis structure for fluorine is going to look like this. All right, so now, how do we know how many bonds an atom can make? Okay, the way that we do that is we look at these solo electrons. So in other words, any electrons that are, let's see, I'm trying to change my color. There we go. See how this works. Any electrons that are alone, meaning they don't have a partner. Okay, so carbon has 4 solo electrons. What that tells us is that carbon can make 4 bonds. Fluorine only has 1 solo electron, 1 unpaired electron. That means fluorine can only make 1 bond. Okay, so we're going to put the element that can make the most bonds in the middle. Okay, so let me get back to a color that I like. And let's look at what the structure for CF4 looks like. Okay, so we've determined carbon can make the most bonds. So carbon's going to go in the middle. And we said carbon has 4 valence electrons. Okay, so let's pick a different color to make fluorine. Let's make fluorine orange. Okay, now it does tell us we have 4 fluorine atoms. Okay, so we're going to put 1 fluorine on each side of our carbon. Okay, and fluorine, we've said, has 7 valence electrons, so let's go ahead and draw those in. It's really, really important, you guys, to draw the Lewis structures of the elements. Don't just draw the elements and then just throw some lines up there to represent bonds, because it's really important that we use the right number of electrons, and drawing your Lewis structures correctly at the beginning of this process is going to make it more likely that your compound will come out drawn correctly. Okay, so we've got my carbon in the middle, and we've got 4 fluorines around the outside. So now what's going to happen, and this is why it's so important to have those solo electrons. The solo electrons are going to form electron pairs, and that's going to form a covalent bond where those electrons are being shared between the 2 atoms. So each fluorine is going to connect to the central carbon with a single covalent bond that I've represented in green. Remember those lines represent 2 electrons. Okay, and notice when I drew the bonds, I connected the electrons. So you really can't see the electrons anymore, you can just see the bonds. I really want you, when you draw your structures, to try to do that, because that shows me that you know those 2 electrons are connected with a covalent bond. They're not just hanging out there on their own. Okay, so now we need to determine the shape. Okay, and to determine the shape, what we have to look at is we have to look at first the number of electron pairs. And this is any pairs, okay, on the central atom. I guess we should make clear that we're always going to be talking about the central atom. Okay, so for this compound, we have 1, 2, 3, we have 4 electron pairs, okay? Then we have to look at the number of lone pairs of electron, again, on the central atom. So in this compound, there are no lone pairs of electrons. Those would be here around the carbon. Okay, so we have 0 lone pairs. So if we follow our points, what we're going to see is CF4 is tetrahedral in shape. Okay, and what this means is that it kind of the atoms spread out around that central atom, kind of like a tripod in 3-dimensional space. Okay, to get as far away from each other as possible. Remember, that's what the whole VSEPR theory says: is electron pairs, because they're negative, they're going to repel each other. They're going to get as far away as possible. Okay, so let's look at our next compound. All right, our next compound is NBr3. So we're going to go through the same process, guys. We're going to draw first. We're going to draw the Lewis dot structures of the individual elements. So we've got nitrogen, and we've got bromine. And this is going to help us to always determine what element goes in the middle of the compound. All right, nitrogen is in group 15. Everything in group 15 has 5 valence electrons. Okay. Bromine is another halogen. It's in group 17. It has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now remember, I told you in class, if you want, wherever you have an electron pair, if you, instead of drawing the 2 dots, if you want to make that the line and have the line represent 2 electrons, that's okay. Okay, I really want you to understand what you're drawing. So you might want to use the electron pairs until you're confident. You know, don't just go willy-nilly throwing in those bonds, okay, if you're not sure that they represent a pair of electrons. So let's draw this using the lines. Okay, so if, as we look at this, the one thing that the reason we drew these first is we wanted to look and see which one of these atoms, which one of these elements has the most solo electrons, and therefore would be in the middle of our molecule. In this case, nitrogen can form 3 bonds, bromine 1. Okay, so nitrogen then is going to go in the middle. Nitrogen has, and I'm going to draw it with the line, so I'm going to draw a line up here that represents those 2 electrons. And then I have 1, 2, 3 solo electrons. Now I'm going to draw, oh, there we go. I need to make my line width a little bit. Oh, there we go. I'm playing around with this program. Sorry, this is the first time I've used it, so I'm kind of experimenting. Okay, so there's nitrogen. Bromine, we need 3 bromines. Br3 tells us 3 bromines. Okay, so Br, and Br. All right, and I'm going to draw, like I said, I'm going to draw the line. So this is representing 2 electrons, 2 electrons, 2 electrons, and then we're going to have a solo electron represented by a dot. Okay. And here we go. My nitrogen dot's kind of out of place, but we're gonna make it work. Okay, so now again, all we have to do, using this method, it makes it really easy to know where the bonds are. We're just gonna look at the solo electrons, the ones that don't have a partner, and we're gonna connect those with a line that represents, and this is just a really bad line, that shouldn't quite be that way, but it is between the bromine and the nitrogen, so I'm going to leave it. Kind of is okay. So if you look at this, nitrogen, like we said, nitrogen can form 3 bonds, bromine can form 1. So this is our Lewis structure. Okay, so now we have to figure out the shape. Okay, so let me change my color again. So we need to first count the electron pairs around the central atom. So I have 1, 2, 3, 4. Okay, so once again, I have 4 electron pairs. In this case, though, this line that's just on the nitrogen, it's not between the bromine and the nitrogen, that represents a lone pair of electrons. Okay, so in this case, we have 4 pairs. One of them is a lone pair. So our molecule shape is going to be a pyramid. And it's almost like the CF4 that we just did, the tetrahedral. But what happens in this one, because it's only got 3 things attached, we have those 2 electrons hanging out up here on the top. And because those are solo, it's a lone pair, they're not solo. It's an unpaired share, unshared pair. Oh my goodness. Those electrons are pushing the other atoms away from it. Okay, so that's why we end up with that pyramidal shape. All right, let's do, I guess I have 2 more. We're going to do OCl3. Oh, excuse me, OCl2. All right, so I'm going to look, let's see, change colors. So OCl2, and I kind of want us to get into this routine so we can just kind of draw the elements and not have to redraw and redraw things, okay? Because I know we don't like to draw things a million times. It takes too much time, right? So I'm going to start out. We know we've got oxygen, all right, and we've got chlorine. So I'm going to draw the oxygen and the chlorine kind of close to each other, and I'm going to then look at what the Lewis structures are while I've got it here ready to draw the bonds, okay, so that I can figure out what element goes in the middle, okay? Hopefully you're starting to see a trend. If we have an element, that there's 1 of that element and 2, 3, or 4 of some other element, the element that there's only 1 of is going to be the one that's in the middle, okay? It always turns out to be the one that can form the most bonds. Oxygen is in group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. Chlorine is another halogen, so it has 7 valence electrons. Now, if we look at this, just like we had been in the other examples, you can see that oxygen has 2 solo electrons, chlorine only has 1, okay? That means oxygen's in the middle, chlorine is on 2 sides, so we're going to go ahead and draw this other chlorine in. I always leave not enough space. All right, so now, again, same thing, guys. We're just, it should be getting a little bit repetitious as we've been practicing this over and over and over. All right, so we are going to connect our solo electrons with covalent bonds. Notice how I went back and made sure that I connected those so they touched. It's really important when you draw these so that I can make sure you know what you're doing, that I can see your electrons and your bonds clearly. Okay, so here we go. We've got OCl2. Now let's look at shape for this thing. Okay, so again, we're going to count electron pairs on the central atom. We've got 1, 2, 3, 4. Okay, so once again, we've got four pairs, but notice this time we have 2 lone pairs. Oops, sorry. That wasn't what I meant. But 2 over here, 2 lone pairs. All right, so 4 with 2 gives us a bent molecule. And once again, these lone pairs of electrons are pushing those chlorines away from them as far as possible. And this is going to be really important when we start talking about having more than one molecule and what that means in terms of its properties. Okay, so one more example. All right, and this one is one that everybody looks at this one like, I don't know how to do this. It's not that bad, I promise. All right, so we're going to do exactly, we're always going to start the way we start. Okay, in this case, we have fluorine. We have 2 fluorine atoms. Now, here's what throws people off. They're like, wait, what's the central atom? Okay, now think about this. If we have 2 fluorines, there's not really a central atom. So anytime you have something, this is something we call diatomic, meaning there's 2 of the same element, okay? Anytime you have something diatomic, or even if you have a binary compound, meaning 2 atoms and only 2 atoms, there's not going to be a central atom, okay? And we're going to look at this. We're going to draw this first, then we're going to talk about the shape because it doesn't follow in our table. So let's do this. So fluorine is a halogen. Once again, halogens have 7 valence electrons because they're in group 17. All right, so if we draw these, notice each fluorine has 1 solo electron, which means that it's going to form 1 bond. All right, so we're going to form a bond right here between these 2 solo electrons, which means fluorine, those 2 fluorine atoms, are connected by a single covalent bond. Now, no matter how you flip this molecule around, it's always going to have the same shape. It's just going to be linear, okay? There's not a central atom. So that's where we, it's like, wait, I want to use the chart. You really can't use the chart. Anytime you have just 2 atoms, whether the same atom or different atoms, anytime you have that, your molecule shape is going to be linear. All right. So guys, I hope that was helpful. It was quick, but hopefully it'll help you see how we draw these covalent compounds and then how we identify the shape. I'll probably put up another video in the next couple of days showing what we do when we have double and triple bonds. We'll talk about that in class later this week. All right, there you go. I hope that helps. See you in class.